Welcome to our lesson on metals, nonmetals and metalloids. As you can see on this periodic table, there are less categories than we labelled in class. We had 10 labelled on our periodic tables in class. Here there are only 3. That's because all of the elements can actually be classified as either metals, nonmetals or metalloids. You can also see on this periodic table that over 75% or 3/4 of all the elements are actually metals. Now, whenever we're doing chemistry, it's worth having a periodic table in front of you. So if you don't have your periodic table from class, then you can visit ptable.com. This is an interactive online periodic table, a very, very handy resource and one that's available to you anywhere that you have access to the internet. All right, the properties of metals. As we remember from our previous topic, metals are very good conductors of both heat and electricity. This allows them to be useful for us in our society, everything from being able to cook with metals to having electricity in our homes. Metals are shiny. Lustrous is the word that's used in science to describe shininess, so this is the term that we'll use from here on in. Metals are also ductile. This means they can be stretched into thin wires, which once again makes them more useful for us. Because we can shape them how we like, it allows us to do things with them that we wouldn't be able to if they had to stay as big blocks. Metals are also malleable. Now this is quite similar to being ductile, but this time it means that we can bend them or pound them flat into sheets. Once again, this makes them much more useful because we can shape them and turn them into whatever it is that we want. The next property of metals is a chemical property. That is, if it's in contact with water, it will undergo a reaction called corrosion or rust. While this isn't a property that we particularly desire, it's one that is important to know about because we need to protect our metals from the exposure to the elements. The last property of metals is that when they're in contact with acids, they will react and release hydrogen gas. I've included a link to another video on YouTube here which goes through this reaction in a lot more detail. There are plenty of videos out there. This one goes through the science quite well and shows you the equations for that reaction. So, some metal examples. One of the ones we've looked at previously is copper. Now, copper is quite distinctive because of its colour. It's also a very good conductor of both heat and electricity. Tungsten. Tungsten has the highest melting point of all of the elements, which makes it useful for us in things like light bulbs where we want it to get very hot but stay a solid. Iron. Most of the things made out of metal in our society are actually made out of iron, everything from cars to buildings to a lot of bicycles. So iron is a very, very useful element for us. Often it's mixed with a little bit of carbon, and that's what we call steel. Mercury. Mercury is the only metal that's actually a liquid at room temperature. While that may seem fun, it's actually highly toxic, and so don't expect to see too much of it around the school. Strontium. Strontium very rarely gets seen in its natural form because it's one of the most reactive elements of all of the elements on the periodic table. Titanium. Titanium is one of the strongest metals that's around, very difficult to break, very resistant to any pressure and changes that are affecting it. And finally, gold, everybody's favourite. As we all know, gold is quite a distinctive colour and very, very valuable, basically because it's pretty. All right, the non-metals. As the name suggests, non-metals are basically the opposite in their properties to all the metals. Metals are good conductors of heat and electricity. Non-metals are poor conductors of heat and electricity. It's hard to show something that's not conducting electricity, so here's a light bulb that's not turned on. Metals are shiny. Non-metals are not. They're dull. Non-metals are not ductile or malleable. Now, sometimes that's because they are gases, and so it's hard to stretch or bend a gas. But often it's because non-metals are actually very brittle. If they are solid and you try to bend them or stretch them, they will snap, they will crumble and fall apart rather than bend. As mentioned, many of the non-metals are actually gases. Here we have some bromine and some neon. So, a few more examples. Sulfur. We actually saw this one before. That was the yellow crumbly solid we saw in the previous slide. Quite a distinctive smell. It's used in a lot of chemical manufacturing, etc. Oxygen. Oxygen is a very important gas for us. It makes up around 20% of our atmosphere, and it's the gas that we breathe and use for respiration to help keep us alive. Argon, one of our noble gases. Like all the noble gases, here you can see it glowing when it's been having electricity pass through it. Chlorine. Once again, another gas here. Chlorine is used in pool cleaning as well as some other chemical manufacturing, but the most common place you'll find it is actually in salt. It's half of the salt that goes on your table, sodium chloride. Carbon. Here we have some coal. Basic carbon, one of the most common elements in the universe and the one that makes up most of your body, in fact. Here we have carbon. This time a different type of carbon. This is graphite. Graphite is what is in the middle of your lead pencils. Not lead, but actually carbon. And the last element that we're going to have a look at here is actually carbon again. Now diamonds are made of carbon as well. Carbon is an incredibly interesting element because it can be arranged in all these different patterns and give you very, very different types of materials. Everything from coal, the burnt bits on your toast, to diamonds. So we'll look at carbon in a bit more detail later on and all the different types or allotropes that it can form. Alright, finally the metalloids. Now, as we said earlier, metalloids are kind of like a metal. That's what the name actually means. They're metal-like. They have some of the properties of metals, but they're not quite metally enough to be a metal. They have some non-metal characteristics, but they're too much like a metal to be a non-metal. Silicon is one of the most commonly seen metalloids. So they do conduct heat and electricity, much better than non-metals, but not as well as the metals. This is a silicon chip. This would be found inside your computer, so it does use electricity, or conduct electricity. Some of them are solids, well they're all solids. Some can be shiny, some are quite dull, metal and non-metal. They can be ductile and malleable. These are some silicon wires. And here are a few examples. As mentioned, silicon. Here we have tellurium, germanium, and antimony. Okay, that brings us to the end of our first video lesson on the metals, metalloids, and non-metals. As I mentioned in the intro, that sometimes there will be a little question to finish off with. Today is not actually going to be a science question. This is just to check whether or not you've made it all the way to the end. I have here my Adelaide United members scarf from 2014. See? So what you need to do to show me that you've watched this video, at the beginning of our next lesson, on a small piece of paper, please write down Adelaide United 2014, hand it to me, and there'll be a little prize in it for you. Okay? Thanks for watching. We'll see you in class.